Hello again, welcome to video number 2 in chemical reactions. In this video you're going to learn how to balance chemical equations. Right, why do we need to balance chemical equations? It's because of the law of conservation of mass, and that tells us that atoms cannot be created or destroyed in chemistry. They can generally be rearranged into forming new substances. And so we've got to make sure that when we write a chemical equation, we've got as many atoms before as we have after, and vice versa. Alright, and how do we balance these chemical equations? Well, we use things called coefficients, which are multipliers, and we put these in front of formulas to multiply everything inside the formula. And by using a combination of coefficients, we can generally balance every equation. What are the rules for balancing chemical equations? Well, not so much rules as steps, but it's a good idea. And we'll go through it longhand version, and then what happens is eventually it becomes intuitive. You just learn it with practice. You do all these steps automatically. You've just got to make sure that you remember some of the steps that you don't use very often. What's the first one? Well, you've got to write down what you're given. So you've got to write down your reactants and your products, and you've got to make sure you use the correct formula. If you don't write the correct formula for something, you're going to be balancing a completely different equation, and you're going to end up with an equation that might be perfectly balanced, but it's not the equation you're asked for. Now, how do you know how to write the correct formulas? You're going to learn that later on when we do ionic and covalent and metallic substances. So at the moment there's a little bit, some of these questions expect you to have a bit of prior knowledge, but I try and fill you in with what you need, and so it can be a little bit confusing as to where these formulas are coming from, but that fog will lift as you learn the skills on writing formulas. And it's a very important skill. Balancing equations and writing correct formulas are two key skills in chemistry that if you don't master when you're first introduced to them, it will make life really difficult when we're doing complicated equations later in the year. So you've got to put in the effort to make sure you understand balancing equations and writing correct formulas when we come to it. Step 2 is you count the number of atoms of each element on the left hand side, and then you do the same on the right hand side, and you compare the numbers of each element, and hopefully they add up. But if they don't add up, you're going to have to then balance the equation. And we'll go through an example of this. A fairly complicated one, but we will. Now you balance it by placing coefficients in front of the formulas. Do not change the formulas. I like to use the example of a simple formula we're comfortable with, water, H2O. Now if you needed, for example, if in balancing your equations, you needed 3 hydrogens, you would not change this formula to give you 3 hydrogens. You would not write it as H3O, because this is no longer water. What you have to do if you want 3 hydrogens or any number of hydrogen is put a number in front of the formula, and that's multiplying everything in the formula. You cannot change formulas at your convenience to balance the equation, because then you're writing a completely different equation. So just look out for that. Right. Now check all atoms or ions to ensure that they are balanced. And we'll be predominantly looking at atoms in this, but when we do ionics, you'll be balancing also ions. And so what you do is you count the elements on the left hand side and the right hand side. You check if they're balanced or not. If they're not balanced, you use coefficients, and you juggle around these coefficients until you get it balanced. And that's not the end of the story. To check that you've got the correct coefficients, you go and recount all the atoms, and they should all balance out. And that's your double check. And finally, in the process, you may have made coefficients quite big. And so the last step is you've got to reduce these coefficients to the lowest possible ratio of whole numbers that you can. And that's a step that sometimes we forget, but we've got to remember that, and we'll get a bit of practice when we do what's called combustion reactions at getting that lowest possible ratio. Let's do an example, fairly complicated one, but we'll work our way through it. So we've got a little bit of noise here at 1000 degrees C, that's just noise. Ammonia gas, and we're given the formula, NH3, reacts with oxygen gas. Now oxygen gas is going to be O2, because that's how oxygen occurs as a gas, to form gaseous nitric oxide, which is NO, and water vapor, which is of course H2O. Write the chemical equation for this reaction. Well, this is straight out of your textbook, so you can go and have a look at this if you want. Reread it at your leisure, or just pause this and read it as we go. So, writing down the information we know, there's our formulas, there's our reactants, there's our products. And if we just did a quick sketch of this, count off the elements and see if they're balanced. Let's start with nitrogen. We've got one nitrogen here. This 3 is 3 hydrogens. It's not 3 nitrogens. There's a little invisible 1 there that we don't write because we write the symbol. And so there's one nitrogen there. There's one nitrogen on this side. So that balances. Yay. Let's look at hydrogens. 3 hydrogens, 2 hydrogens. So the hydrogens don't balance. Now we can stop there because we know we've got to balance the equation. And so we have to go through all the steps of balancing the equations. But let's just check the oxygens. Oxygens 2, oxygens 2. Okay, so that looks like the only problem we have is the hydrogens. Now it's not that simple, because when we go to fix the unbalanced in the hydrogens, so when we balance the hydrogens, what will happen is, because each of these hydrogens is in a formula, and we'll be putting coefficients in front of these formulas, balancing the hydrogen then has a flow-on effect. And that flow-on effect is to cause other elements to become unbalanced, and we have to balance them as well. So it gets a bit complicated. It does sometimes. So this is what they've said. They've worked out that the hydrogens aren't balanced. So how do we balance them? Well, to begin the balance, we correct the hydrogens. And so we can see here, let's get my little pen. We can see here, we can see here that they've put a 2 in front of the ammonia and a 3 in front of the water. And that now gives us 2 times 3, 6 hydrogens. 3 times 2, 6 hydrogens. But the flow-on effect is now, this time, we now have 2 nitrogens over here, because it's 2 times everything. Remember, this is the same as writing 2 bracket NH3, and in maths we worked out that 2 times everything in the bracket. Everything in the bracket. These invisible brackets, I'm not encouraging you to draw these brackets because we don't do that in chemistry. But they're invisible brackets. Okay? Much like there's an invisible 1 there. Okay? Much like there's an invisible 1 just down here. But we don't have to write them. Gets confusing? Yeah. Alright. So, let's go back. Let's change colours. Okay? So we've got a 2 there. And we've got a 3 there. That gives us nitrogens. No, that gives us balanced hydrogens. But we've now got 2 nitrogens and 1 nitrogen. And over here, we've got 1 oxygen plus 3 oxygens. Because that's 3 times oxygen. So that's 4 oxygens. And here we've only got 2 oxygens. So it's actually made the situation worse. Okay, so now an imbalance in nitrogen has occurred. To balance the nitrogen atoms, they add a coefficient of 2. So they put this 2 here now. Now that's 2 nitrogens there, 2 nitrogens there. Now can you see the flow-on effect of that though? How are our oxygens going? So we've balanced hydrogen, we've balanced nitrogen. What about our oxygens? Well, we've only got 2 oxygens on this side. We've got 2 plus 3. So we've got 5 oxygens on this side. So we've got 2 oxygens and we've got 5 oxygens. So we need to balance the oxygens. And that's what the next step is. Let's bring it up. Right. Now to balance the oxygens, because we had 2 on the left and 5 on the right, we introduce a coefficient of 2.5. Now this is a little bit tricky, and not everyone uses this technique. This is where you use a fraction to balance, and you only use the fraction for the very last thing that you need to balance. So we've got the hydrogens balanced, we've got the nitrogens balanced, and we use this half here because 2.5 times 2 equals 5 oxygens, doesn't it? And because here we have 2 oxygens plus 3 oxygens. Alright, so that 2.5 gives us our 5 oxygens, and it balances it. And it's a tricky little technique to use, and we don't use it very often, but we will use it, and I recommend that you use it. So make sure you understand what they just did there. And then, now of course you can't have half an oxygen molecule. What you then have to do is get rid of this half by multiplying each of these coefficients. So what would you multiply each of these coefficients by to get rid of the half? You multiply them by 2. And so that becomes 4, this becomes 5, 2, and 3. And these, now that these are whole numbers, they're our coefficients. And that's the simplest possible ratio that you can have, and that's what we end up with. So if we make it appear, there we go. Okay, but it's not the simplest ratio. So since the usual practice is to have whole number coefficients, multiply the entire coefficients by 2. And there you go. And there's the answer. Now that's a pretty complicated one. What I want you to have a go at in class is we'll do this question here and we'll have a go at it. Let's just have a quick talk you through the first one. But remember, you're doing this in class. Now I won't write the subscripts because that just takes a little bit of time. And so the first one, we've got nitrogen gas reacting with hydrogen gas to form something called ammonia gas. And you can see that this doesn't balance. 2 nitrogens, 1 nitrogen, 2 hydrogens, 3 hydrogens. So if we tried to balance the nitrogens first, we would just, let's get a different colour, we would put a 2 there, because that now gives us 2 nitrogens. But the flow-on effect of that is we've now got 6 hydrogens. So how do we get 6 hydrogens on this side? What do we put in front of here to give us 6? Well, clearly it's a 3. Then last step is we check our balancing. 2 nitrogens, 2 nitrogens, 6 hydrogens, 6 hydrogens. It's balanced. Alright, so in class you're going to do these questions and see how you go. You're going to do a lot of them actually. The answers are there, but they're also in your textbook and they're on your OneNote. And then I'm also going to give you this sheet here, which has about 25 or so of these, and so you're going to do a lot of practice at balancing, and everyone can get some help if you need it. So we'll do this all in class, and by the end of it you should be a wizard at balancing chemical equations. We're also going to do this question here, which is a bit trickier because these are balanced but there's something wrong with them, and I'll talk to you about these in class. And finally, we're just about to move on different types of chemical reactions, and the types of different chemical reactions we're going to actually study now are precipitation reactions, where we get something precipitated, but also include what's called dissociation reactions, when we take a solid and dissolve it. We're going to also look at acid, base and neutralization reactions, and we're going to look at combustion reactions. And so we're going to be able to write and balance these different types of equations. The precipitation reactions are particularly complicated, but once you nail them, they're pretty good. They make sense. Alright, so in the next video we'll start looking at ionic equations, and that will lead us on to precipitation. Ionic compounds, and that will lead us on to precipitation reactions. Sort of repeated myself there, but I think I got it right. Alright, cheerio!